With the increased usage of AI coding assistants, I think we are starting to realize that implementation has become less important than systems and specifications. Let's explore this topic today. Welcome back to Think Design Work Smart. I'm Alex Bolbak and I'm coming at you from the MosaicWorks studios. And today I want to explore this impact of AI coding assistants over the work of software development. And I think if before we were very focused on knowing programming languages in detail, mastering the syntax, mastering the implementation details, knowing precisely how technologies interact with each other, I think what happens with AI coding assistants is that you can generate those parts, or you can generate good enough first drafts that you can then modify, as long as the problem is clear and as long as you can test it. So then the focus moves on to figuring out how to specify these things and how to test these things such that maybe we can end up with small modules that have a very clear functionality and that you can feed into an AI agent so that it can review it, generate the code. If there are issues, regenerate the code. And then the thing that we need to do as software engineers more and more is figuring out what the problem is, splitting the problem into smaller problems, and then for each problem define what are the success criteria or the testing criteria, and let assistants or agents do the implementation. And then you can test against those. And I would argue that this can push the architecture to an even interesting or more interesting way of organizing. Imagine that instead of having big code bases, what you have is very small focus modules that act as black boxes. You can test each of those. You know precisely what needs to be into them because you specify that ideally through code, through tests, through specifications as the example, through behavior-driven development, through test-driven development, through contracts. And you verify also that they interact in the right ways together, and that together they move towards and they provide the behaviors that you want from your system. And if something doesn't work, you just go into one of these black boxes and say, okay, let's rewrite it. And you just regenerate it based on the new, you add a new test that specifies the bug that you need to avoid, and then you regenerate based on that. And it's as easy as that. So if this is the case, if we can end up with this scenario, then it's no longer important to know how to write code. Well, it is important to learn how to write code in order to understand the level of precision that you need. But you no longer need to write the code. What you need to do is to make sure that the thing behaves in the right way. And so the onus moves and the focus moves towards systems. How can we structure these systems? What are the things that we need to pay attention to? Are there specific algorithms that we need to build into these modules, and so on? And this to me looks like it's more and more a potential way of building software in the future. It feels like this is where we are heading towards. I don't know if it will be with agents or maybe with assistants or with loops or with whatever, trend of the day is discussed in AI circles. But the reality is that code, syntax, implementation details in probably 95% of the cases will no longer be that relevant. Now, there are hurdles against this hypothesis. So let's assume that we have these black boxes. Now, The question is, are there situations when this can hit us? The thing with these black boxes, so ideally they would be encapsulated, they will have high cohesion, low coupling, which means that they do one thing well. Think about the Unix philosophy, think about what we discussed on this channel, things, not pipes. Think about real modularity. So real modularity would mean that I can drop that module and replace it with another module that has the same contract but different implementation that favors other operational concerns. So maybe one is more secure, the other is more performant, and I can pick the one that I want based on the shape that I need. The thing with this is, though, that it's possible these black box modules would have duplication between them. In fact, it's very likely. So there is a potential for introducing bugs that affect more than one module if we have duplication between them and if the bug hits on that part of the system. And so if this happens, then what you need to do is to loop through each module and regenerate the implementation so that those bugs are no longer there, which means a lot of work. So that's one thing that could hit us, and we know it's possible. Another thing is operational. So we've seen with microservices that they require all kinds of juggling and careful juggling on operational side. And this would be, in a way, an extension of microservices only. The difference is, what I mean by these modules is they could also run in the same process or in different processes. So or you can start and stop, or can have various types of behaviors. And then the question is, can we achieve performance, reliability, security that we want with such a modular architecture? And I think this is still an open question. What I would expect will happen in the future if we go on this path is that new primitives will appear in operating system that allows us to run these applications or run these modules in the different scenarios so that the performance is not affected that much, because you can do all kinds of smart things with process prioritization and things like that. So yeah, there might be a problem, but not by the end of this stage. I mean, optimizations are possible here. Hardware optimizations are also possible, because if we switch to such a model, then maybe also hardware will switch to a model that allows us to run, I don't know, processes in parallels or pipelines or whatever we need. So I wouldn't worry that much about this part. It will be a worry for a while, but it will eventually go away. Reliability can become a concern, because reliability becomes more complex with more moving pieces. We've seen this again with microservices. You need things like circuit breakers and so on. But again, those can become primitives in this new way of structuring your architecture. And this leaves us with the biggest problem of them all. This type of architecture is not fit for human modification. If you generate the architecture in this way, but then you take away the AI assistants, you are left with a lot of code that you don't fully understand and that you are afraid to change, and with less knowledge about the implementation details that you will need if you need to write specific parts of the implementation yourself without assistance. So this indeed becomes a big problem. And connected to this is the problem of costs. we don't know precisely where the real costs for AI will land. Right now we are in a transition period. We started from really cheap subscriptions compared to the consumption of the companies that offer us these services. We are now switching towards token-based payment, but it's still not at the level where they can make a profit. So that means that either they will improve their infrastructure to optimize their costs, or they will pass some of the costs to the client. And so the question becomes, does it make sense in that case to use these services? And that's a question that we'll need to answer. So while there is this force that I think is pushing towards this kind of architecture, this will probably happen on newer projects or on newer components. Somebody will have to be brave enough to attempt it, and they may well become the next Spotify model, in the sense that Spotify model in Agile was something that Spotify did and then spread around the tech community. A lot of organizations adopted or said they wanted to adopt that model. They didn't actually understand the Spotify model because Spotify was not using that, but so that's a whole thing there. But the important thing is there was one thing like that, and a lot of companies adopted it. And that's similar to what happened with microservices. So part of it is real, in the sense that it makes sense, you can adopt it and so on, and it's a good framework. But part of it is also fashion, marketing, whatever an organization did, and then it sounds good to executives. So it's possible that at some point, some companies will start using this model. They will become the new, let's say, Netflix with microservices. A lot of companies will start adopting that, and then we'll face a new change in software architecture that uses this kind of black box modules. So this is a potential future. I think we are heading to some version of it. I think in order to get there, what we need to do is to have more clearly defined contracts on the API level, on the between components and databases or data stores of any kind. And once we have those, we can use some of the techniques that we already have: architectural tests, property-based tests, example-based tests, plus these contracts, behavior-driven development, specification by example, and build documentation at the same time as the architecture. And then most of the effort will move towards figuring out the problems, figuring out how to split the problems, making experiments on what's the best way to implement the problems, and constraining the implementation so that they reach the level of behavior and of operational constraints that we need. And I expect this will happen sooner or later. And then at some point, conversations about programming languages will be at the same level with conversations about tabs versus spaces. That's a bold statement to end with. And so I'm really curious to hear what you think about it. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.